So the first unit and first section of the unit is 1.1 rates of change and the slope of a curve. So this is basically, we'll use this as a refresher from the functions course that you took before. So we had learned 2 rates of change and 2 slopes from the functions course. And then in section 1.2, we will look at using an equation. So part A, key ideas. Secant is a line that intersects with a curve at 2 points. So we'll talk about that down below here. The slope of the secant line represents the average rate of change of a function over an interval. And to determine the slope of the secant line, or what we will call the average rate of change between 2 points, this would be my formula. The average rate of change is equal to the slope, right, from grade 9, y2 minus y1 over x2 minus x1, or in other words, just changing. I think I have this too thick, 1 sec. The change in my y's over the difference of my x values. So average rate of change, we can just use AROC for short. And this is also slope from grade 9, which we'll now refer to as the average rate of change. So let's say this is my graph, this is my curve. This part here is my function, f of x, let's say. This is 1 point, P1, that's on the graph. This is another point. And so the secant line, this straight line here, is going through 2 portions of the f of x graph. It's going through 2 parts, and this is my secant line, this line right here. So let's just use a different color rather than writing secant line again, right? This is my secant line right here. Okay, so for my tangent line, tangent is a line that intersects with a curve, but only at 1 point. You can see only 1 point here in the example. The slope of the tangent line, the slope of this line here, represents the instantaneous, at that moment, instantaneous rate of change, which we will call IROC for short, of a function at 1 specific point, at just that specific point. The point at which the tangent line touches the curve is called the tangent point. So this point right here, this P, is the tangent point. The tangent line is this line here that's going through my function. So let's say over here, I'll call it g of x, just so it's not called f of x, which was a different graph from before. So this is my function g of x. Here is a tangent line that is only going to cross and come into contact with that function once, and it's coming into contact at the tangent point, and that is called the tangent line. To determine an estimate of the slope of the tangent line, or the instantaneous rate of change, and the reason why it's an estimate is, again, to get the slope, I need 2 points, correct? So because I only have 1 point given to me, it's going to be an estimate. I don't have 2 points given. I need to calculate the average rate of change, which we will talk about. So again, the average rate of change over the smallest interval. So between that point and a point right beside it on the right or right beside it on the left. Or I can determine the slope of the tangent line itself from the graph. So keep in mind, both methods are limited by the data that's given in the table, if I'm given a table of values, or the accuracy of the sketch that I'm looking at, right? So from this smallest interval here, I'm probably going to be getting that information from a table, which we'll see in our example. And if I determined the slope of the tangent line on the graph, I would be determining the instantaneous rate of change. Okay, so let's look at an example. A hot tub that holds 1,500 liters of water takes 1 hour to drain. The table shows the volume of water that remains in the hot tub. So obviously the initial value here is 1,500. I don't know why. I don't know if I can change that now in the graph to make it bigger. Because I don't know why that is, that the numbers, yeah, sorry, I can't change those two, but it's 1,500 and 1,215. The rest looks okay. So determine the average rate of change. So determine the, just a rate for short, the average rate of change of volume of water that is in the tub between 12 minutes and 42 minutes. So average rate of change, again, is from the secant line. We're looking at 2 points. So it also tells us in the question, it gives us a hint, right, that we're working with 2 points because it has the word between, right? Between 12 minutes, so this number here, and between 42 minutes. So in this time frame between these numbers, in this half hour, what is the average rate of change between those 2 points? So again, to read my table of values, this would be my X, this would be my Y, I'll just try to fit it up here so it doesn't go as part of the question, but the independent variable in this question is your X, which is time. Time is usually on the X-axis, right? And my dependent variable is volume. Okay. So the 2 points that I'm going to be using then are X first, so the 12 first, and 960 is the Y value. And the other point that it's asking me to use is 42 and 135. So those are my X, Y coordinates, independent and then dependent, right? So my average rate of change, right, formula is the slope formula, which is the change in my Y's over the change in my X's. And just to also get used to, here it's not actually listed as an X and a Y value. I could say the change in my, what are the Y values? The volume, change in my volume, divided by the change in my X value, time. And that's also going to help me with what I would write as my therefore statement, what my units will be at the end, based on, so volume and time would be liters per minute, right? And then I simply use the formula of Y2 minus Y1 divided by over top of X2 minus X1. So let's say this is, for some of you, it still might help to label. So if we wanted to change, if this was my X1 and this was my Y1, this is my X second point, this is the Y value of the second point, and then just go from there. So Y2 minus Y1 would be 135, take away 960, divided by the X value of 42 minus 12. And just to point out, I could have also put 960 first minus 135. So if I had 960 first and I'm starting with Y1, then on the denominator, I have to start with X1. Then it should say 12 minus 42. And either way, I should get the same answer. Just if I'm starting, let's say in this direction, this minus this, let's say your arrow will go in that direction, then I have to go in that direction here. This minus this. So here using a calculator, I have negative 825, and that would be volume, so that would be liters over 30, and time is in minutes. And go ahead and divide that to get an actual decimal, and I have negative 27.5 liters per minute. So I'm losing, so determine the average rate of change. So the average rate of change is I'm losing, let's write it out, 27.5 liters on average per minute, each minute, between, I'm going to put that for between 12 and 42 minutes in that half-hour time frame. In that 30-minute time span. Okay? So now using the values in the table, now we want to estimate the instantaneous rate of change of the volume of water when we're at 12 minutes. So just before I move up here to answer B, the instantaneous rate of change is the tangent line, which would only intersect the graph at one point. And there's also a hint here that it's only at one point because it's only giving me one value at 12 minutes. Now, I don't have a graph for this question, right? So if we looked up above, let's go back. The two ways to answer this here is determine the slope of the tangent line on the graph or calculate the average rate of change over the smallest interval. So we will have to calculate the average rate of change over the smallest interval. So what is the smallest interval? So if I'm looking at 12 minutes here, use a different color, pink, 12 minutes here. What I would really like to have is at, again, a value right beside the 12. So at 12.00001 minutes, I would like to have the volume number there. Or if it's preceding that, and at 11.99999 minutes, what is the value? But I don't have those values in the table. I have values that, in terms of decimals, are somewhat far away, right? I have 6 minutes after at 18 minutes, and I have 6 minutes before at 6 minutes. So depending on what the table shows, whether you choose a point that's on the left or on the right, you want to choose the point that's the closest to 12. So in this case, 6 and 18 are equidistant away. It doesn't matter which one I choose. So let's just say randomly I choose the point 18 minutes and 735 liters. And that will help me get my instantaneous rate of change, which will be an estimate, right? Which is fine, that's what it's saying. I'm going to estimate that for the 12-minute mark. So I want an instantaneous rate of change at one point in time. Just to write this out for your notes. That would be at one point in time, which is at 12 minutes. But in order to get that instantaneous rate of change, because I don't have a graph, then I need to get it from the table. So I need to choose to the left of it or to the right of it, whichever is closer. So if you want to write that down, I'm going to write down my points here. So before I move this, we're at 12 and 960 and 18 and 735. So if I move this up. Okay, let's rewrite those points. I have minutes as 12 minutes with 960 liters. And then I'm choosing the one to the right of it just randomly. I could have chosen the one to the left and went with 6 minutes, but 18 and 735. And then again, I have to figure out the average rate of change. So again, my change in Y or change in V over my change in X or change in time. So I'm going to start the same way as before. I'm going to say this is X1, Y1, first point, second point, X2, Y2. So 735, take away 960, all over from starting here. I have to start here, 18 minus 12, which I have an answer of negative 225, which is volume, which is liters, over 6 minutes. And go ahead and divide that on the calculator. And we have negative 37.5 liters per minute. So again, that means that I'm estimating the instantaneous rate of change at 12 minutes. I'd be losing 37.5 liters per minute at that moment. So therefore, I would write it out as, therefore, the instantaneous rate of change is equal to, but an estimate, so don't forget the dot on top of the equal sign, negative 37.5 liters per minute at 12 minutes. And don't forget, this is an estimate. You don't have to write that out. I'm just mentioning it's an estimate. So this isn't exactly. If you happen to choose the number that was to the left, if you happen to choose the X value of 6 in the table, you might get a slightly different answer. But again, the point is that we should be close and it's an estimate. So as long as we're close. Okay, the following is the graph. So it's all the same question, right? The following is a graph that represents the volume of water in the hot tub, but now it's in graphical form. Use the graph to also estimate the instantaneous rate of change of the volume at 12 minutes. So same question, 12 minutes. So we have negative 37.5 algebraically, solving by average rate of change. How would we solve by looking at it from the graph? So if I'm looking at the instantaneous rate of change at 12 minutes, then this is my tangent point, right? That would be the tangent line is only coming in contact with the graph once. And so at that point there that they're talking about is my tangent point. So I'm going to draw a tangent line that crosses that point. So since at that point, the graph is decreasing, then the tangent line has to be negative as well. So the line that I'm drawing has to go in accordance with if the graph is decreasing or increasing. So my tangent line will have a, let's just write that out. My tangent line will have a negative slope. My tangent line should have a negative slope. Okay. So we need to draw the tangent line and then we need to find the slope of that line. So first, let's say draw the tangent line. And then number 2, determine the slope of that line. Okay. Now, I don't know how good of a job I'm going to do here. I tried practicing this once before I started recording the video, and I wasn't able to, if I go, see, the way I've drawn, it's kind of cutting through 40 here. So if I, let's say, have a line like this, I don't know how to select this line and then extend it. So essentially I'm making 2 lines that might not line up well, but I'll do my best again. Okay, that looks not too bad, except it's looking like it's hitting at more than one point here. If I can erase this. Again, it's not going to be perfect with the way that it's drawn, but it's supposed to look like it's only going through this pink point here and that it's not touching anywhere else on the graph. So let's say, I don't know, that's better, I guess. Let's say it looked like that. And then what I'm determining is the slope of that line. So how do I get the slope of that line? I need to choose 2 points that are on the slope of that line, right? The one point, though, that should be obvious to choose is I should be choosing the point that they're giving me, which is 12. And I would be guessing what the value is off the graph. So I know that's more than halfway. I know it's more than 900. So whether you chose 950, but from the table of values above, I have that exact value. So I know I should choose 12 and 960 as one of my points. Then it's just a matter of what would my other point be. So when I drew this, you don't have to go along with me. So let's say this point happened to come in contact here with the x-axis at 36. You could choose the point 36 and 0. The way I had drawn it originally was at 40, 40 and 0. But if I'm looking here, it looks like it's crossing at x is 0 and y is 1400. So I can choose any point I'd like along that line. Maybe that's intersecting the grid lines, like nice whole numbers. So I'm going to choose, and again, you can choose a different number, but I'm going to choose 0 and 1400. And then just figure out my, I should be able to fit it here, instantaneous rate of change. It's going to be equal to, but again, it's an estimate, so don't forget the dot above, the change in y over the change in x, or change in volume over the change in time. So here I'm going to have, oh, let's say I do 1400 then, minus 960, all over 0, take away 12. So that would be 440 all over negative 12, right, liters per minute, which would end up being, and again, don't forget your dot above the equal sign, approximately negative 36 point, I think it was 666, so I just made it negative 36.7 liters per minute. So that's an estimate, right, on what the instantaneous rate of change is at that 12-minute mark. And if we look at the question before, that was also asking us to estimate the instantaneous rate of change at 12 minutes. I got an answer of negative 37.5. So this is not exact, but it's close to 37.5. Okay, for the next question, for the following graph, which is down here, describe and compare the instantaneous rate of change at the points indicated. So there's 6 points here, 1, 2, 3, 4, 5, 6. I want to know which 2 points have an instantaneous rate of change that is 0. I want to know which 2 points have an instantaneous rate of change that is negative, and which 2 points have an instantaneous rate of change where it would be positive. So looking at this graph, again, like I said before, if I'm following the graph and if the graph is decreasing and in a downward position, then the instantaneous rate of change will have to have a negative slope is the way I should draw it. If the graph is positive and increasing, then my instantaneous rate of change will have a positive slope. And if I'm at a turning point, which would be right here at a minimum value or a maximum value, if I'm at a turning point you learned from last year, then my tangent line, right, because it says instantaneous rate of change, so that would be with the tangent line, will be completely horizontal. So again, I don't know how good of a job I'm going to do here. Let's try my best. This one should be somewhat easy. So here's my horizontal line, and I should make that a little bit thicker. So there's my tangent line. Okay, so search, yeah, that's not, I have to go more vertical. Yeah, let's erase that one. Try again. Oh. Or go from here first, like I said, and technically just make 2 that look like 1. Let's say like that. And where it's positive, right, draw my line like that. So let's call these points A, B, just in order from left to right, because that's how I should read a graph, is from left to right. C, D, this point it will be E, and finally F. Which of those points have a rate of change of 0 or a slope of 0 is the same thing, right? So we've learned from grade 9 that the slope of 0 is a horizontal line, which would happen at the turning point of B and D. At which 2 points is the instantaneous rate of change negative? That's when my slope is negative. So at point A and at point F. And where is it positive? Would be when I'm increasing on the graph at point C and point E. Okay, so let's just go back up and write that in. Which 2 points is the instantaneous rate of change 0, where my slope is horizontal? So where my at point B and at point D. Which 2 points is the instantaneous rate of change negative? That would be at point A and at point F. And where is the graph increasing, where the instantaneous rate of change is positive, is at point C and also at point E.